Okay. You guys want to hear a little bit about Cosmos?
Let's do it.
I'm Maghnus. I'm one of the co-CEOs of Interchain Labs, which is basically the labs entity for Cosmos. And I want to chat a little bit about, some very high-level stuff about how Cosmos works and the tech stack and some things that you might not have realized. So one cool thing is the presentation previously, the L1 built is actually built on Cosmos technology. So this is going to go a little bit further in depth about how you build an L1 in Cosmos and all the benefits and basically design decisions that go into that. Let me see if this works. Yes? No? Yes. So the thesis of Cosmos was basically to build an internet of blockchains, right? So it launched in about 2017. And back then, really, the only two things that existed were Bitcoin and Ethereum. And Cosmos's thesis was, well, there's going to be more of these, right? This was before rollups or even a word, right? And so it built a stack that let people much more easily build their own blockchains. Initially, that started with the Cosmos Hub, and then it expanded to now over 120 chains and powers the majority of the L1s that you see today. So, for example, Berachain is a Cosmos chain. Athena will be building a Cosmos chain. Babylon, Initia, like many chains that are sort of Ondo chain, like all of these are built on top of this open core tech stack. And the idea initially was, what is the internet going to look like in the future? The internet is probably going to look like something like a set of security assumptions that can interoperate seamlessly. And that's what sort of brings us to this concept of IBC. So this is a rough view of Cosmos right now. A lot of chains are not here, but these are some. And all of these are independent L1s, right? So you have chains like Mantra Chain, DYDX, Cosmos Hub, Celestia. These are all IBC connected to each other. And IBC is basically a permissionless transport protocol that lets these, it's essentially a bridge that lets these interoperate. So I think the reason that Cosmos has stuck around for, at this point, almost 8 years, is it gives you full control over what you want to build. It's the only stack where you can essentially customize the exact hardware that you want to run on and do that in a fully censorship-resistant and verifiable way. Verifiable is the most important part. So it also means that you can you have no economic dependencies on anyone else. You're not rolling up into anything. You're not depending on anything. You're not consuming the security of anything. You are fully on your own. You are fully your own blockchain, which is a little scary for a lot, but has traditionally excited the most ambitious teams that believe that they can build their own L1, like a Bitcoin or like an Ethereum or like a BNB chain, which, by the way, is also using Cosmos Tech, BNB chain. The other thing is that Cosmos was designed to be natively interoperable. So IBC is baked into the chain itself, which makes it natively interoperable with any other chain that has fast finality, traditionally. Which means essentially in 4 seconds, you can go from your chain and transfer assets to any other chain. It was the first blockchain ecosystem to really build with interop in mind. I think as we're seeing now, Ethereum is struggling to figure out its interop standard between all the different L2s. We believe that this could actually be IBC, but we'll go into that in the future. The other thing is DYDX and Hyperliquid both chose Cosmos Tech to build their L1s. The reason for that is because you can run your own infrastructure, it can be extremely fast, like unbelievably fast. So we regularly see 400 millisecond block times, 20,000 TPS. You can really turn it into whatever you want. And so if you have a fast scaled application, Cosmos is a really good choice. So this is essentially what I was saying before. IBC is this bridge that interoperates all these different protocols, does roughly $1 to $3 billion, making it the third largest bridge by volume. There's over 150 chains, and there's over $100 billion of TVL. It's just some ecosystem stats. I sort of went over this, but I'm going to go a little bit more in depth into a couple of these things. So Comet BFT is the consensus algorithm that is open source and permissionless, and you can use it. it was probably the first real production-ready BFT consensus mechanism that uses proof of stake that was ever created. It's very interesting. If I could recommend one white paper, it's probably the Tendermint white paper by Jaquan. It's incredibly fascinating. IBC is this secure interop protocol, and then the Cosmos SDK is the application logic of your chain. So starting with Comet BFT. So Comet BFT is a fast finality Byzantine fault tolerant consensus algorithm. It has been co-opted into many, or it has been forked and then changed into many of the existing consensus algorithms that we know today, like Hot Stuff on Aptos, or I forget the names. There's so many of them. Kronos' thing, Ouroboros on Cardano even. But the fundamental premise of it is that it's delegated proof of stake, which means it's not like Ethereum. You delegate to a validator, and then 2/3 of the stake that is delegated needs to vote on the next block. The most important part about it, though, is that it's fast finality, which means that the block finalizes when the block finishes, right? You don't have to wait 19 minutes for, basically probabilistic finality, which makes IBC, which is a bridge, extremely fast, right? Because all you have to do is wait for the finality of one chain and the other. So all the IBC transactions take less than 5 seconds, right? Versus bridging from Ethereum to Solana does not take 5 seconds, unfortunately. The Cosmos SDK is what sits under the stack. This is the module layer. This is where basically you build your custom application logic. So for example, DYDX built their own in-memory order book to go really fast as a module. Another interesting example would be you could build your own native auction module. Or if you're Osmosis, you build your own native DEX. And this is built into the chain, which means you can create your own custom transaction types, right? There's no VM involved. This is not EVM. This is not SVM. It's not MoveVM. It's native transactions that you build into your chain. And it lets you do some really interesting things. So for example, if you're Osmosis, they have their native DEX module. They built another module in it called ProtoRev, which basically automatically arbitrages their own DEX. So on every transaction, as it gets executed through the state machine, it will automatically arbitrage and then return that money as protocol revenue. Last year, this generated $9 million for them. And they used that to fund their development team. You can customize the entire MEV and UX stack on top of your actual state machine, which is impossible to do anywhere else. And this makes for some really, really powerful applications where you can customize at that layer versus just at the VM layer. And the cool thing is you can combine a VM with this functionality and then expose it inside the VM. So for example, you can have a smart contract that now has new transaction types it can call. For example, you could add a new transaction type to the EVM that says, hey, I want you to arbitrage this transaction, or I want you to relay this packet to Solana as a single transaction, right? And you don't even need a smart contract. It's embedded in the chain. That's what we call precompiles. So this is getting extremely powerful now. Oh, here. And the last thing is IBC, right? So IBC is a light client bridge, which basically means you prove the state on one chain and the other. It is not a multi-sig bridge, right? So it is unlike Layer 0 or Axelar or Wormhole, which basically rely upon an external multi-sig to sign on the validity of the bridge transactions. This instead uses your own validator set. So the native stake that secures your chain also secures your bridge, and it's run by your own infra, meaning you don't have to use an external bridge, right? There's no Layer 0 integration. There's no Axelar integration. There's no Wormhole. There's just you and your validators and another chain that has the same, which makes it, 1, completely free, 2, completely open source and interoperable, and 3, actually works without a third-party vendor, and which makes it basically extremely exciting for people who want to customize their own interoperability protocol and do so without changing the security assumptions of their chain. One of the things that I find really difficult and really, I guess, emotionally challenging is that we are increasingly relying upon bridges that are 2 of 2 multisigs. So like Layer 0 is, for example, this. And it's challenging for me because this is miles ahead of whatever I see on the market. And it only has not expanded beyond sort of Cosmos because it did not have an integration into the existing L1s outside of Cosmos. That's now changed with IBC V2. So with V2, you no longer need a Tendermint chain on the other side. You can use any smart contract platform. And the way that we do that is actually with ZK. So what we do is we deploy a Eureka smart contract on the destination, let's call it Ethereum. And then we use that to interoperate with the other Cosmos chain. And then we use ZK proving to prove the light client on Ethereum. We've gotten it down to be really fast. It only costs 150,000 gas, which makes bridging from, I'll come back to that, which makes bridging from Ethereum to any Cosmos chain, whether that's Berachain, Babylon, BNB chain, Kronos, the Cosmos Hub, whatever other Cosmos chain, $2, which is an incredible feat because the cheapest alternative, that's a third-party bridge, costs $63, even today. So I think one of the core things that we wanted to bring to Ethereum and even outside of Ethereum, and of course within Cosmos, is a completely game-changing interop protocol. And because of ZK, finally the tech is there, right? Finally we can create this. So one of the things that we're doing with Eureka is we are now connecting all of the different Cosmos chains and all of the existing large L1s and making sure they're fully interoperable. And then the next stage is to connect all the L2s. And I firmly believe that this is literally going to be probably the most used interop protocol just because of how interop is playing out in the rollup ecosystem, where most things are now done by solvers, and basically people are fronting capital. All those solvers eventually need to settle their tokens. When they see this price difference, they're going to route over the cheapest and most secure option. So this is something we worked on for about 3 to 4 years. And this is roughly the design decisions that went into it. So previously, you had clients. So 2 clients, as I talked about before, on different chains talking to each other. They formed a connection, which was essentially an authenticated handshake. And then they had a channel, which was basically a pipe to transfer data over. And then finally, you had applications that used the former 3 to transfer tokens. In V2, this is completely rethought. You do have clients, but one client is a smart contract, or both clients are smart contracts. Then you have a single router, and then the applications can directly use those smart contracts. So this is actually live on testnet, and we're going to be live with Eureka on Ethereum March 27th. And so if you're building anything on an EVM, or anything in the Ethereum ecosystem, or anything, of course, on the Cosmos side, you can use these smart contracts natively and trigger calls for $1, right, or $2 to transfer. So we're really excited about this. I think that was, I kept this very short, which, I'm not entirely sure if that was a good decision, but I thought, if folks have questions, I'm very happy to delve into things in more detail. Yeah.
Could you dig a little bit further into the V2 flow over there? We have this router. Is that a relayer, or what is it exactly?
Yeah. So basically, to leverage V2, there's 2 ways of using it. The first one is to have a direct connection to Ethereum, right? This basically means you need to instantiate your own smart contract that proves the light client of your chain, if you're a Cosmos chain. And that means you also have to run a relayer, as you said, and a prover, right? And it doesn't come with any additional infrastructure. It's an open source code base. So you just have to implement it and set up all the infrastructure. The other one is to connect over traditional IBC to the Cosmos Hub. And the Cosmos Hub has an aggregated connection for a bunch of different chains to Ethereum. And that's beneficial because, and that's the router, right? And that's beneficial because we can batch the proving cost. So it actually comes down, it comes down to even significantly less than this because we can essentially just send one giant proof instead of just individually proving each packet. And it also means that we can provide all of our infrastructure around market makers to make this transfer in less than 30 seconds. So at the end of the day, it costs $2 and is in less than 30 seconds, which is just incredible, right? So that's where the router comes in. So if people want to create their own, I keep going the wrong way. If people want to create their own implementation, they can do that. But it's expensive, right, to run all that infrastructure. And so we made this router essentially available for folks to essentially have an easier and cheaper path.
How does this look like for non-Ethereum, like say Solana?
It's the same exact thing. We just would have to build the smart contract in Solana on the SVM. Yeah, so that's also the sort of use case for the router, which is instead of having to connect your chain to every other chain, like Solana, Ethereum, Bitcoin, etc., the hub can just do all of that and aggregate all the connections. And so all you need to do is have a simple IBC connection to the hub. And then you can just basically route all of that through.
What are the, I guess, pros and cons of someone who wants to build an app chain, Cosmos versus launching an Ethereum L2?
Yeah, so I guess like going back to a couple of these things about who this is good for. Where was that? So I guess like, do you have an inkling of like what it could be?
Well, I guess like, well, this is all the benefits, but I guess there's cons too. Like you have to go and find all the validators. You have to find people to be your validators. You have to create a new token to be the stake essentially. But I guess the advantage is that you can actually build something that's substantially more performant. Does that sum it up, or is there more?
Yeah, so finding validators for sure. But in practice, this is a lot easier than people make it out to be. I mean, you just message Telegram and you get 20 validators. Like they're all, you just look at another chain and like they have their email link. You're just like, hello, will you validate our chain? And they're like, of course, like send me the binary. So that actually usually takes like 2 days, which I would argue is like a similar time to like choosing like, oh, should I use Conduit or like some other thing on an L2? But it does take time, right? And you have to manage those relationships is the other thing. In regards to like launching your own token, you don't actually have to do this. So for example, Noble, which is the native USD issuance inside of Cosmos, they don't have any token. And the way that they do that is their proof of authority. So basically they have the same exact model, but they essentially gave one token to every validator, an immutable token. And so they still have to have consensus of the validators, but there's just no tokens involved. And the reputation there or the security there comes from the fact that their validators are extremely reputable, right? They're like Circle. They're people that you would not expect to be colluding. And if they do, like crypto's over, right? That kind of thing.
Right, like you can just set it up as a federation, basically.
Exactly. It's like federated architecture. That's right.
Cool.
Any other downsides? I mean, I would have said traditionally a huge downside was this interoperability question with Ethereum, right? It's like you have this wonderful IBC ecosystem between the chains, but as soon as you leave to Ethereum, now you have your 19-minute Axelar transaction, right? That costs $63. It's horrible, right? That's no longer the case.
Right. What are the advancements for Bitcoin within getting Bitcoin into Cosmos? I think there was one team that was trying to build some type of bridge. I can't remember the name.
Yeah, there's a couple Bitcoin bridges actually. So have you heard of Thorchain? Yeah, so Thorchain unfortunately collapsed because of their over leverage, but they acquired, or maybe they forked the Bifrost bridge, which is an open source implementation, and they actually had most of the bridging volume in crypto. Replacing them now is the Nomic bridge, which is, they've worked on that thing for like 14 years. They finally came out with it. Most complicated system we've ever seen, but they're live and they have a Bitcoin bridge. But probably the most exciting one right now is Babylon, which is Bitcoin restaking. It's kind of like EigenLayer for Bitcoin. They launched a Cosmos chain, and what they did with it is they partnered with all of these new LST Bitcoin providers like Lombard, LBTC, all these different things, and they're moving all of that liquidity into Cosmos through IBC V2. And then also Lombard, in that case, is building their own Bitcoin bridge as an attestation network. They're building their own Cosmos chain, which they're using to become an attestation network for Bitcoin. So I expect you'll see most of the like liquid stake Bitcoin liquidity in Cosmos over the next like year or two.
Gotcha. Cool.
Yeah.
How does a question about Comet? How does
Yeah.
that work for like DAG chain instead of like a
Mm-hmm.
acyclic graph chain instead of a linear chain.
Are you guys familiar with Narwhal or Tusk? Heard of it before? Narwhal was a very cool consensus mechanism. I believe some chain tried to use it. It's very advanced, but it's exactly what you're saying. It's an acyclic or directed acyclic graph implementation, and I would argue the two are quite different, right? So, for example, Narwhal is not a fast finality protocol, and the reason for that is without getting too technical, is essentially you have like a probabilistic finality on a per node basis, right? Generally, things that use acyclic graphs and that kind of like state consensus mechanism have really fast block execution times, but they have slower finality because they have to make sacrifices. In consensus design, there's, almost everywhere else, there's sort of a triangle, right? So it's like finality time, execution speed, and security. And so Tendermint went all the way to security and finality time, whereas something like Narwhal or Tusk goes all the way to execution time. I think, doesn't Aptos have some kind of acyclic graph thing? Yeah, anyway. Some people try to do it.
Thanks. Thank you.
Thank you.